Hi everyone. Today I'm going to talk about reinforcing stairs. Plain concrete is too weak to resist tension and shear. Therefore, it cannot be used when these stresses are of considerable magnitude. By embedding steel bars in the concrete so arranged that they carry the tensile and shear stresses, which the concrete by itself is unable to resist. A very valuable building material, reinforced concrete, is obtained. The possibility of combining reinforcing stairs with concrete is due to the following factors. 1. The concrete contracts when setting in air and tends to grip the stair, causing two materials to adhere. The concrete is able, therefore, to transmit to the stair those stresses which it cannot carry. 2. The linear coefficients of expansion by heat of concrete and steel are very nearly equal. Hence, two serious stresses due to variation in temperature occur. 3. The coating of concrete protects the steel from corrosion. 4. The fire resistance of unprotected steel is impaired by its high thermal conductivity. On the contrary, the thermal conductivity of concrete is relatively low. Thus, damage caused by even prolonged fire exposure is generally limited to the outer layer of concrete. A moderate amount of concrete cover provides sufficient thermal insulation for the embedded reinforcement. It is important that steel and concrete deform together, i.e., that there be a sufficiently strong bond between the two materials so that no relative movements of the steel bars and the cells and the surrounding concrete occur. This bond is provided by the relatively large chemical adhesion which develops at the steel-concrete interface by the natural roughness of the hot rolled reinforcing bars and by the artificial roughness of the surface of deformed bars having notches and protections intended to increase the bond between the concrete and the steel. Furthermore, the ends of all tension and shear steel bars should be provided with a hooked end to prevent them from splitting in the concrete. Various types of reinforcing steels are used in structural members such as beams, columns, and slabs. In beams, longitudinal bars are located close to the tension face to resist diagonal stresses. Stirrups may be used for such a purpose. In square columns, which are actually loaded, longitudinal bars and transverse small diameter steel ties are used. Round columns are reinforced with longitudinal bars surrounded by a closely spaced spiral. Wire meshes are largely used for floor slab, and in other positions where it is convenient to introduce the reinforcement in sheets instead of single bars.